Hello to you all. I'm Vincent Jericho C. David. I'm part as a pledge member representative of Midterm Exam Activity Video Tutorial 3, which is about finding area of a triangle using matrices and determinants. Now, before we get our glimpse on this lesson part the coverage talked about, we now discuss a quick brief about both matrices and determinants. Matrices, or matrix, is a rectangular array of numbers or elements which comprise the focus depicted on focus first the rows followed by columns at each number positioned. And determinant is a number associated with square matrices comprised of a denoted by a depicted letter given the opposite equal of a number which arranged with. Solving the area of a triangle using matrices and determinants will give a glimpse sight of a challenging equal solution to our problem what we rely on. This is my given example of this triangle, so I'll be no pain to solve entirely as I depict of this given graph position with a shaped triangle and its points. Here I have a solved given detail, whereas A consists point 7 and 4, B -5 and 6, and C is -3 and 0. Here's why I solve entirely as I'll give a solution to this problem. Now here's what I give the whole solution to this area of a triangle example 1. But I gotta say it, I instantaneously equal both its determinant and the area itself. So what I did first off is to look of all 3 rows but written down its first 2 columns. So I write 7, -5, and -3 with 4, 6, and 0. Next up is I diagonally down all 3 first, which consists 7 times 6 times 1 plus 4 times 1 times -3, and with plus 1 times -5 and plus 0. Then brought down minus straight to the opposite at the top, all 3, which given me as -3 times 6 times 1 plus 0 times 1 times 7, and with plus 1 times -5 and 4. So I brought equally each set of numbers, as I 7 times 6 times 1 equals 42, 4 times 1 times -3 is -12, and we brought only 1 times -5 times -0 times 0, it is now just 0. Then brought the next 3, -1 times 6 times 1 equals -18, and with 0 times 1 times 7, just now 0. And last, 1 times -5 times 4 equals -20. So brought an old equation to the next part is 42 minus 12 just now equal to 30. And with the other one is negative 18 plus 0 and minus 20 is equals to negative 38. So within both signs have the same, so it will turn plus. So I brought it 30 plus 38 is equals of a detriment to 68. So that means 68 is what's missing part, and the last is the area. So given 68 over 2 is relate on 34 square units is the answer, is the whole answer to the first given example. So moving to the next given. So now you've seen the first example that I have solved of its area in a triangle. So we give with this next second example I have with this triangle covered up. Now you've seen the whole solution from example 1 have given. So I'm consisting now looking this second example I have solved, but not directly yet with determinant and area itself. So once again, looking at all 3 rows, but written down its first 2 columns as a focus, with 8, 2, and negative 4, with 0, 6, and negative 2. Then diagonally down its first set, which I have brought 8 times 6 times 1 plus 0 times 1 times negative 4 plus 1 times 2 times negative 2 minus it, then diagonally up the opposite way, which I have now with negative 4 times 6 times 1 plus negative 2 times 1 times 8 plus 1 times 2 and times 0. So I have 8 times 6 times 1 into 48 with 0 times 1 times negative 4, just 0. And 1 times 2 times negative 2 is negative 4. So go along with negative 4 times 1 and times 6 is now turned negative 24. Times 2 times 1 times 8 equals negative 16. And last, 1 times 2 times 0 is it now just 0. So I brought in 48 minus 4 is just now 44. And with negative 24 plus negative 16 turns negative 40. With both signs are the same, turn into plus. So what's equally 44 plus 40 is equals to 84 as determined. So but in 84 as determined in area solution equaled out 84 divided by 2 is in relate area equaled 42 square units. That's why I give in all 2 examples in this tutorial.